Another rational expression multiplied to each other. First glance, I'm just starting to see some big numbers here and some things that I might want to think about. And first of all is, well, maybe there's a way that I can cancel some of my work before I can continue. So I'm looking at that other side there and I'm seeing, well, let's factor it down and maybe we're going to have some clever versions of 1 present themselves. Again, I always like writing down the problem every single time I make a change. It helps me understand what I'm doing. It also helps me understand that if I miss something, I'm able to come back and clarify and figure out where my mistake was. I'm going to factor the numerator over here. It looks like I get x plus a 5. And the denominator on the other side, 7 times x minus a 3. Now everything is in its completely factored form. I can multiply straight across, or maybe something cancels out through a clever version of 1. And that's what I see. An x minus 3. Over here I have an x minus 3. Well, what that means is let's multiply it all out first. So x minus 3 times a 10 times an x plus a 5. And the denominator, x plus a 5, a 7, and an x minus 3. All I did is I multiplied fractions as I normally would. Numerator times numerator, denominator times denominator. This one just looks a little funny because there's some x's and binomials in the way. But if you practice them, you start to see them just like any other number. So I wrote them all as one fraction, and then in that fraction, I'm going to start to see things cancel out. X plus a 5 over an x plus a 5, I will cancel those, because that's essentially a clever version of 1. X minus 3 and another x minus 3. And now all I'm left with is a 10 divided by a 7. And that's my solution. I can't cancel any farther. There's no other factors in common. It's completely reduced. I'm done. Hallelujah. Let's go home.